All right, so let me go over those. First of all, when you have a situation here where this negative itself is not in the parentheses with the 3, it's only the 3 that's being squared. So you're going to do the exponent first, then you're going to multiply by -1. Okay, so that happens first there. So 3 squared is 9. That's going to become -9. And again, I'm going to do parentheses first. So that's -45. And I'm going to keep it in parentheses because all of it is being raised to the third. And then you might want to use a calculator for that. -91,125. All right, for the next one, again, I focus on the parentheses first. Before I distribute that negative power, I'm going to see what I can simplify inside. 1 to the 4th is just 1, and 3 squared is 9. All right, so that's being raised to the -2nd. So using that very last rule that we did up here, right? When you have a quotient raised to a negative exponent, switch the place of the numerator and denominator, and the exponent becomes positive. And that will be positive 81. All right. So here I have c to the first. If you don't see an exponent, you can assume that the exponent is a 1. It's a quotient with the same bases, right? The bases are the same. So I'm going to subtract the exponents. And that is going to become 1 minus a -4. So that is c to the 5th. And then I multiply the two exponents using the rule. It'll be c to the -15th. So when you do have a negative exponent in your answer, we do try to encourage you to write your final answer with a positive exponent. So in this case, you would move that to the denominator and make that a positive 15 for the exponent. Number 2. There's a couple ways that you might approach doing this problem. I personally like to simplify the numerators and denominators. So I notice in the numerator here, I have 2 bases that are the same, the x. So I am going to use the rule. It says that I should add those exponents. So that's going to become x to the 2nd and then y to the 2nd. In the denominator, I'm not changing anything, just rewriting it. Now I'll use the quotient rule. These two have the same base, so I'll subtract their exponents. These two have the same base, and I will subtract their exponents. 2 minus 4 is -2, and 2 minus -2 will become 2 plus 2, so 4. Again, if I rewrite this so that all my exponents are positive, this one will move to the denominator, and I'll have x squared in the denominator. And the last one here, even though there's this big multiplication sign there in the middle, really everything in the numerator is being multiplied together. So all of this I could multiply together, and all of this I could multiply together. I also can do some simplifying right off the bat if I wanted to. For example, 3 goes into 6, and I can simplify that. But I'm going to use the approach where I simplify the numerator first and the denominator, and then do some canceling. So here I have 2 bases that are the same. So I'm going to add those exponents. And I'm going to put things in order so that it goes number and then variables and in numerical order or alphabetical order. So this is going to become 6x to the 3rd and then y to the 1st, -2 plus 3. In the denominator, I have 3. I'm going to put the x first before the y, just so that it's in alphabetical order and easier for me to see. Now again, 3 does go into 6 twice, so I'm going to do some canceling there, And then I'm going to subtract the exponents. So 3 goes into 6 twice, so I have a 2 here in the numerator. 3 minus -4 is going to be 7, and 1 minus 2 is -1. Now notice I didn't write that in the denominator. When you subtract the exponents, that answer is in the numerator. If it's negative, then you move it to the denominator. So this is just over 1. And then now I'm going to move that to the denominator, making it +1 exponent. All right, switching gears. We're going to focus a little bit on scientific notation. And the reason is we're going to use some of our rules to multiply and divide scientific numbers written in scientific notation in an easier way, in a faster way using the properties. So in order for some number to be in scientific notation, it has to be of the form of a number times 10 to a power. So some number times 10 to a power. That number A has to be between 1 and 10. It can be equal to 1, but it can't be equal to 10. It can also be positive or negative, so that's why the absolute value of A is there. The exponent has to be an integer. This is rewritten here in this box, okay, for you, a little bit nicer. And in order for us to get something in scientific notation, what we do is we move the decimal so that we get a number between 1 and 10. And then for every place that we've moved the decimal, we've basically multiplied it by 10 or we've divided it by 10, which would be 10 to a negative number. So if I move the decimal over 3 places, that would be multiplying it by 1,000 or 10 to the third. If I had to make the number from a small number go to a bigger number, that means I'm multiplying by 10 to a negative number. So for example, express the number in scientific notation. So right now the decimal is here, but it is not a number between 1 and 10. So I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7 places to make it 5.6. And since I moved it 7 places, that's my exponent. Now, the reason it's a negative exponent, think about this, 5.6, that's a big number, but this is a really small number, right? So you're multiplying it by a very small number to get it to be 0.00000, 5.00056, right? For this one, I'm going to move the decimal 3, 4, 5, 6, 7 places, this time to the left. So I have 9.01 times 10 to the 7th. Now, if we're going in the other direction, we're going to take it from scientific notation to standard notation. If the number is a positive exponent, that means you're going to move the decimal to the right. That means this is getting bigger overall, the number's getting bigger. If this is a negative exponent, that means that this number is going to get smaller, so you're going to move the decimal to the left. So I'm going to move 3 to the right for this one, which would be 1,350. And for the other one, I'm going to move 4 decimals to the left. So it was here, and then you move 4 to the left, and then you also put another 0 in front of that decimal. All right, so that's a review of scientific notation, but we're actually now going to use the properties that we learned to do some multiplication and division a little bit faster. So in order to multiply two numbers that are in scientific notation, notice that this is really just 4 different things being multiplied. I have 1, 2, 3, 4 things being multiplied. So I'm going to multiply the 5.2 and the 1.3 together, and then I'm going to add the exponents using the rule. The bases are the same, so I just add the exponents, right? So I'm going to get the 5.2 times the 1.3, which gives me the 6.76 times 10 to the 8th. Now this number is between 1 and 10, so the whole thing is fine. But in this example here, this is not going to be a number between 1 and 10. When I multiply the two numbers, it's more than 10. So I'm going to have to move the decimal another place. So let's think about this. When I make a number that's bigger, and I have to make it smaller so it becomes between 1 and 10, I need to compensate by how many tens I'm multiplying by. So sorry about that, let's try that again. So if I move the decimal from here between the 4 and the 8 to in between the 3 and the 4, I've made this number smaller. I've essentially divided it by 10. So to compensate for that, I need to multiply by another 10. I need to make this a little bit bigger. So I made a bigger number smaller. So I need to make the power of 10 bigger. And whatever decimal places you moved, that's how much you change that exponent. If you're dividing, you're going to use the same rules that we've been using, where if the bases are the same, you're going to subtract the exponents, but you're going to divide this like normal. So 1.1 divided by 5.5 is 0.2 times 10 to the 6th, the negative 3 minus a negative 9. But again, this is not in scientific notation, so we have to move this decimal over one place. That's going to make this number bigger. So to compensate, I'm going to make this one smaller. I'm moving this one decimal place, so I'm going to take 1 away from that 6. Okay.